1/2 plus 1/4 plus 1/8 plus 1/16, and on forever. Infinitely many numbers, every single one of them positive. You would expect that total to run away to infinity. It does not. It lands on 1. Not close to 1, exactly 1. By the end of this video, that will not feel like a paradox. It will feel unavoidable, and you will have the formula for every geometric series, whether it stops or not. A series is geometric when each term comes from the one before it by multiplying by the same number every time. Call the first term a, and call that multiplier r. So the terms are a, then ar, then ar squared, and so on. With n terms, the last one is ar to the n minus 1. Adding these is awkward, but multiplying them is effortless. So let us use the multiplying. Here is the whole trick. Multiply the entire sum by r. Every term simply shifts one place along. A becomes AR, and AR becomes AR squared. The new sum is almost identical to the old one. It has just slid across by a single step. So subtract one from the other, and watch the middle of the page. AR appears in both rows, so it cancels. AR squared appears in both rows, so it cancels. Every single term in the middle destroys itself. Only two survive. The A at the front of the first row, and the AR to the end at the end of the second. Now it is ordinary algebra. Pull S out of the left-hand side, and pull A out of the right. Then divide both sides by 1 minus r, and there is the formula for a geometric series with n terms. Notice that it never required adding a single pair of terms. It came entirely from that one slide, and the cancellation it caused. Now, the case that started this video. What if the series never stops? Take r equal to 1/2 and watch it as area. Color in half of a square, then half of what is left, then half of what is left after that. Each piece is genuinely half the size of the one before, so this is a geometric series, and the pieces are filling the square. They never spill outside it, and every gap eventually gets covered. That picture is exactly what r to the n going to 0 looks like. If r sits strictly between -1 and 1, multiplying by it again and again crushes the term toward nothing. So the r to the n inside our formula simply disappears, and the sum settles at a over 1 minus r. For the square, a is 1/2 and r is 1/2. 1/2 divided by 1/2. Exactly 1, just as promised. So an infinite sum is not a paradox. It is a square being filled. And the formula you were told to memorize is simply what is left standing after almost every term has canceled itself out.